Hello everyone, this is for Algebra 2 for doing change of base with logarithms. And for starting out, what you guys need to appreciate here is that this I can't type in the calculator because on your calculator you have a log base 10 button and you have an ln button, which once again is a log base e button. So I can't type in log base 5 of 7. It wants to know 5 to what power is 7. But I can't type it in because I don't have a base 5 button. Again, you got base 10 and base E. So to do change of base, I'm going to motivate for you why this is going to work, why this shortcut of typing this in this way. Like, for example, this is the correct answer for this is going to be log of 5 divided by log of 4. This one would be log of 8 divided by log of 3. And remember, when I'm leaving out, it's like if I just write this symbol, you guys understand that's a square root. Okay? So I'm leaving out the base, so it means base 10. Okay? Why is log base 3 of 8 the same as log of 8 divided by log of 3? That's what I want to motivate for you. When you guys go to do these problems, absolutely, you don't have to do the steps I'm going to show you here. You would just write log of 8/16 over log of 5. But I could train a rhesus monkey to do this. You guys are much smarter than that. I need you to understand why you're doing what you're doing. The why is as important as anything else you guys do. You don't just blindly do something. You have to know why you're doing it. To help you see it, I'm going to pretend we got a variable with it. Okay, pretending perhaps isn't a great way to go, but I'm going to translate this into this. This is the same thing as that. It's saying 5 to what power is 7? 5 to what power is 7? Okay. Imagine that you had this problem and you want to undo that square. There was something that you did to both sides to solve for it. Same idea is going to hold true here. There's something I have to do to both sides of this in order to solve. The buttons again that you had on your calculator for logarithms are log base 10 and log base E. In other words, your ln button. I'm going to choose to do a log of both sides. So I'm going to take the logarithm of both sides. So this would become log base 10 of 5 to the x is equal to log of 7. Now, what are the properties that you guys have been using? That was base 10. You don't need to write the base 10, but I'm just doing it to emphasize the point. One of the properties that you guys have is that when you have an exponent inside a logarithm, that exponent drops in front as a product. That's one of the rules that you guys had to memorize. So that's x times, when I drop that in front, log of 5 equals log of 7. Now I want to solve for x. This is held by multiplication, so I divide it out. So your answer to this, doing the change of base formula, is log, I guess I don't have enough room there. Let me erase that. I'll write it down here just because I have more room. That's going to be log of 7 divided by log of 5. Log of 7 divided by log of 5. But this is why you're doing it. This process of why you're doing it. You're just applying the rules for logarithms that you already know. Okay? So, to go through and do this process again, this would become log of 7 divided by log of 5. So this would be log of 5 divided by log of 4. And you guys need to be a little bit careful when you go to type these in your calculator. As soon as you hit the log button, a parenthesis is going to form. This fraction bar means divide. So when you go to type it in, you type in log, boom, parenthesis is there, 5. Before you hit the division symbol, make sure you close that parenthesis. Otherwise, what you're going to get is log of 5 over log of 4, and that's all going to be inside that logarithm, which is not what you want to do. So make sure you close that parenthesis before you hit log and then close that paren 4. Okay, this is base 10. There's nothing to do here. That one's completely fine. I'm throwing this in as a red herring or a trick to see if you guys catch it. This would be log of 8 divided by log of 3. That already is base 10. There's nothing more to do. This isn't base 10, so I need to type it in a way that would let me get it in the calculator. So I'm going to choose base 10 to type it. Log of 6 divided by log of 8. Log of 256 divided by log of 12. Okay. So that's the change of base. All right. Here, it's kind of like a free-for-all. Do what you got to do to solve this sucker. Okay? Using any of the methods, strategies you guys have seen so far. So here goes. When in doubt, translate it. See how this has a logarithm? This doesn't have a logarithm. This is exponential form. When in doubt, the first thing you guys should do is translate them. Write it in logarithmic form. Log base 5 of 625 is x. Boom, there it is. You're done. You solved for x. Okay? It'd be great if you guys type that in your calculator to see what it should be. So in other words, you could go log of 625 over log of 5, and doing that real quick. Yikes! Didn't have the calculator ready. I apologize. So log of 625, close the paren, log of 5, and you get 4. So the answer to this is 4. Okay. This one, when in doubt, translate it. It says log base of a half of 32 is equal to x. You may not recognize what that is, as a hiccup off the top of your head, but if you do the change of base formula on it, you can find it. So that's log of 32 divided by log of a half. So again, you do the change of base so you did the change of base. Now you're going to type it in your calculator, and I believe you're going to get 5, isn't it? So let's try it. Log of 32, negative 5, sorry, divided by log of a half. Yep, negative 5. Okay. When in doubt, translate it. Log base e of 2 is x. And log base e is worth ln, so that's the ln of 2 is x. Now, notice there's nothing here that says round your answer to the nearest blah, blah, blah. So if you were to type that in your calculator, ln 2, you're going to get 0.6931447 blah, 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 blah. No, don't write that. Yuck. Just leave it as ln 2. Okay? This is in logarithmic form. When in doubt, translate out of it. If you need to see the intermediate step of what this says, then by all means write it. If you're able to jump straight to e to the negative 7 is x, then by all means jump to it. But this is that. Okay? Like I said, if it helps you writing this intermediate step, so it reminds you that the base e is there, then by all means do it. Okay? Don't type it in your calculator again, you'll get an absolute gross number. When in doubt, translate. 4 to the third is x. Boom. I don't think you guys need to write that as 64. I think you can leave it just like that. When in doubt, translate. X to the fourth is equal to 625. To solve this, you guys would take a fourth root of both sides. Now normally when you guys take an even root, you put a positive or negative down. And the fourth root of 625 is 5. But there's the rule that says no negative bases. So it's just 5. So x is equal to 5 is your only answer. Okay. This would require the change of base. So that's log of 4 divided by log 3. Okay, type it in your calculator, and you'll see you get a decimal. So I would leave it right there. Okay. Same deal with this one. Log of 6 over log of 5. This, it's in exponential form. If you need to, translate it first by writing log base e, and then you go, log base e is ln, so ln is 7, is x. This one, I'm going to prime factor this a bit to help you guys see what this is. So 16 is 2 and 8, 2 and 4, 2 and 2. So this is 2 to the 2x plus 1 equals 2 to the 4th. Now, think about this for a second. 2 to some power is equal to 2 to the 4th. The only way this is ever going to be true is if this power equals 4. So, 2x plus 1 equals 4. Subtract the 1 divided by 2, and x is equal to 3/2, and you got it. All I did was prime factor this and go, the only way these are ever going to be equal, because the bases are equal, the only way they'll ever be equal is if their exponents are equal. So I set their exponents equal to each other. Subtracted the 1 divided by 2. Boom! So pretty easy when you look at it that way. Doesn't even need a logarithm. Okay? That's log base 10. This is saying, what is the exponent on 10 that gives you 10 to the 6? It's saying 10 to what power is 10 to the 6? Oh, x is equal to 6. So what you need to see is, when the base of the logarithm matches the base inside the logarithm, they cancel out, and you're left with 6. When the base of the logarithm matches the base that's inside, they cancel out. When the base matches the base, they cancel out. When the base matches the base, they cancel out. Okay, this is log base e of e to the 5th. Okay, there you go.